Functions in C. So the objectives of this video is for the user to be able to write user-defined functions in C, and for the user to be able to use a standard library in C, or understand how to use a standard library in C. Although our main focus here will be on user-defined functions. C functions. A function is a block of code that performs a specific task. Dividing complex problem into small components makes program easy to understand and use. A function is a group of statements that together perform a task. Every C program has at least one function, which is actually the main function. And all the most trivial programs can be defined or can define additional functions. So we can include a lot of functions. It depends on maybe the complexity of the program. Type of functions. Depending on whether a function is defined by the user or already included in C compilers, there are two types of functions in C. We have the standard library functions and the user-defined functions. So what are the differences? So this will be discussed on the next slide. So here we have the standard library function. The standard library functions are built-in functions in C programming to handle tasks such as mathematical computations, input-output processing, string handling, and others. So these functions are defined in the header file. When you include the header file, these functions are available for use. The printf is a standard library function to send formatted output to the screen, and this function is defined in the standard io.h header file. So we include this header file for us to be able to use the printf statement. If we remove this one, then this will not be recognized by the compiler. We also have what we call the user-defined functions. So C language allows programmer to define functions. Such functions created by the user are called user-defined functions. So depending upon the complexity and the requirement of the program, you can create many user-defined functions as you want. And here are some of the advantages of user-defined function. So if you use user-defined function, the program will be easier to understand. So that is maybe because we divide codes into modules, and instead of looking at the source code as a whole, you can look at the source code per module, per functionality, and that will make the program easier to understand. And then the code can be reusable, so reusable codes that can be used in other programs. So if our functions are designed in such a way that it can be used in other programs, then we can just copy and paste our functions in other programs. A large program can be divided into smaller modules. Hence, a large project can be divided among many programmers. So you can assign, let's say this module will be assigned to another programmer, and another module will be to another programmer. So we can work as a team. Now, how do we define functions? So defining a function. The general form of a function definition in C is as follows. First, we have the return type, followed by the function name, and followed by the parameter list. Then we have open curly brace and close curly brace, and inside this curly braces will be the body of the function. So what are these? So they will be defined here. So a function definition in C consists of a function header and function body. So we have the function header and the function body. So in the header, we have the return type, function header. A function will return a value. The return type is a data type, so it can be an integer, float, character, or others. So of the value the function returns. So it depends on what the function returns. If the function does not return a value, then the return type is void. So take note of that. If it does not return a value, then the return type is void. Then the function name is the actual name of the function. The function name and the parameter list together constitute the function signature. So the function name and the parameter list. Parameters. So a parameter is like a placeholder. When a function is invoked, you pass a value to the parameter. And by the way, parameters are optional. Then next we have the function body. The function body contains the collection of statements that define what the function does. So here is an example. So given below is a source code of a function called max. This function takes two parameters, num1 and num2, and returns the maximum value between the two. So here, let's take a look at the parts. This is the return type, this is the function name, and these are our parameters. And here is the function body. So here in this function, this returns the higher value between these two parameters. So the body of code now is we declared a local variable name result. Then we compared if num1 is higher than num2. So if this is higher, then the result should be equal to num1 because that's the higher value. If not, so that's else, result is equal to num2. So the result here now will contain the higher value. So the function will just return the value of result. So you notice result is an integer. That's why our return data type is also an integer. Now, how do we declare a function? A function declaration tells the compiler about a function name and how to call the function. The actual body of the function can be defined separately. And usually, that is what I do. I define, the body is defined for me separately. That is making use of a top-down approach. A function declaration has the following parts: the return type, function name, and parameter list. So for example, we have int, that's a return type, max, that's a function name, and we have the parameter list. So that is how we declare functions. And how do we call a function? So while creating a C function, you give a definition to what the function has to do. So, and to use the function now, is you will have to call that function to perform the defined task. When the program calls a function, the program control is transferred to the call function. A called function performs a defined task, and when its return statement is executed, or when its function ending closing brace is reached, it returns the program control back to the main program or to where it was called. To call the function, pass the required parameters along with the function name. And if the function returns a value, then you can store the return value. So here is now an example. So what we did here is we define or we declare the function. So we have integer max, int num1, comma int num2, semicolon. So we did not yet define the body of the function. And this is our main function. So we have integer a equals 100, integer b equals 200, integer red. And then here, this is where we call the function. So red is equal to, we have the function name, and then we pass the parameters. So what we pass here are 100 and 200. When the function is called, the control will pass to the function. So we have max, so num1 is equal to the value passed. It is actually 100, and num2 is 200. So result, we declared result. If num1 is 100, is it higher than 200? So no. So it goes to this particular place, or the control goes to the else block. So we have result is equal to num2, which num2 is 200, and then return the result. So 200. So this function returns 200. So 200 will be stored in this variable. So ret is now equal to 200. So we have printf max value is %d net. So the value of ret will be placed here, which is actually 200. So the max value is 200. So again, this is how we declare functions, and we can write the functions after the value of the function after our main program. And this is how we call functions. Function arguments. If a function is to use arguments, it must declare variables that accept the values of the arguments. These variables are called formal parameters of the function. Formal parameters behave like other local variables inside the function and are created upon entry into the function and destroyed upon exit. So they are like local variables. They are created once we enter the function and destroyed once we exit the function. Two ways in which arguments can be passed to a function is by calling it by value or called by reference. By default, C call by value uses call by value to pass arguments. So in the previous example, this is an example of calling by value, but in a way it will be again discussed later. Call by value. The call by value method of passing arguments to a function copies the actual value of an argument into the formal parameter of the function. In this case, changes made to the parameter inside the function have no effect. So take note of that. Changes inside the function have no effect to the argument, because what we pass are only the values, not the argument, or not the original value. So original variable. So here we have a function to swap values. So we declare the function here. Although there's a little mistake here in my code. So I have here swapping the value. So this will pass x and y, and then we have temp. So the value of x is placed to temp, the value of y is placed to x, and the value of temp is placed to y. So logically, this will interchange the value of x and y. But let's see what will happen with this one. So here we have a equals 100, b equals 200. So we print the value of a, that's 100. We print the value of b, that's 200. Then we call this function swap. There's something wrong with this. There should be no ampersand here. Should only be swap a and b. Sorry for that. So what we did here is to pass the value of a and b. So the value of a is 100, so x is 100, b is 200. Again, temp. So 100 is placed to temp, 200 is placed to x, so x is now 200. Temp is 100 a while ago, then 100 is placed to y. So x becomes 200 and y becomes 100. But again, we only pass the value. So this will not affect a and b. That's why if you're going to print the value of a and b after swapping, they still remain the same. So we only pass the value. In contrast, what we have the pass by reference. The call by reference method of passing arguments to a function copies the address of an argument into the formal parameter. Inside the function, the address is used to access the actual argument used in the call. It means that the changes made to the parameter affect the pass argument. So that's the difference. So here there will be, and it will affect the pass argument. To pass a value by reference, argument pointers are passed to the function. So argument pointers, that means we're going to pass the address. just like any other value. So accordingly, you need to declare the function parameters as pointer types. So here we declared the function. So you notice of the changes. So I use here asterisk x and asterisk y. So that means they are pointers. And then, we have here a equals 100. Oh no, this is the original one. So you notice in the original one, we don't have asterisk here. So these are not pointers. So in the new example, we have here pointers. So we have asterisk x and asterisk y. So a equals 100, b equals 200. We print the original values. So we have our original values. Then we swap a and b. So you notice here that we pass the address of a and address of b. So here we have pointers, temp. So the value of stored in the address x is placed to temp. The value stored in y is placed to the value of x. The value in temp is placed to the value of y. And since we pass the address, this will affect the values of our parameters. That's why after this, if we print the value of a and b, you notice that they are now swapped because what we pass is the address. So that's it for this lecture. So what we have done here is we have differentiated a user-defined function with standard library function. We also have discussed how to declare functions, what are the parts of the functions, and how to call functions, and how to call by value, and how to call by reference. Thank you very much for viewing this video.